Hi, hello everyone. Welcome, 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 welcome to another video, another lecture. आपका अपना सबका सपना, right? It's my channel. I can say whatever I want, whatever I want. Understand? That's the beauty of it. That's the beauty of your own channel. You can speak whatever you want. No one is going to question you. I am the only one having the authority. I am the only one who can question, and I'm the only one who's going to answer as well. Because it's a one-way communication, online teaching. Anyhow, let's continue. So in last class, we were solving questions based on motion in a straight line. So we have done a lot of questions. Around 9 questions we have done. So this is a 10th question. So after this, we'll do something good, right? I have tried doing something. I have tried deleting, I have tried making it or black and white. So this really puts a lot of light on my face, right? Nice. I could have done for this question as well, but anyhow, right? Should I do it right in front of you? Yes, you can learn this. It will be helpful for you as well. What do you have to do? You have to share. Go to don't go anywhere. You go to, where can you go? You go to Snapseed. You go to Snapseed, you put on edit, go to curves, just like this you do, and voila, that's done. So I have successfully converted this one as well into what I wanted, right? Okay, great. Just a moment. What do we have here? Nothing is there as such. Okay, great. Let us start. So let us see this question, question number 10. So now I think there's lighting, proper lighting on my face as well, since I have done this. Right, so the question says the speed time graph for a body moving along a straight line is shown in the figure. They have given the speed time graph, the average acceleration of the body may be. We need to figure out the average acceleration, right? Seems like an interesting question. Let us see how to solve this one. Okay, so we have the speed time graph. We need average acceleration. What exactly is average acceleration? So see, average acceleration is change in velocity by change in time. That's the concept here. Okay, average acceleration is change in velocity by change in time. So you can write it as v2 minus v1 by t2 minus t1, right? Now this is a very interesting question. Why is it interesting? Because there are multiple possibilities here. So we have to explore all the possibilities. There are multiple possibilities for the answer in this particular question. What are the multiple possibilities? So one is, this is a speed time graph, right? How will the velocity time graph for this particular case look like? How will the velocity time graph for this particular situation look like? So velocity time graph could be any way, right? I want to just stretch a little bit. Yes, hoo ha, do a little bit of warm up. Yeah, champion, 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 champion. Yeah, that's how you study. Great. Now you see here, this is speed time graph. What we can do here, v2 minus v1. So one thing is that the velocity time graph for this particular graph could be exactly like this, how it is the speed time graph, right? Another possibility is that velocity could be negative. So actually there are other possibilities as well. So based on the different possibilities that you have for velocity time graph, we can get different answers, right? What is the one of the possibility? One of the possibility is this only, right? Or let me do one thing. Let me make it simple, and let me just chalk out all the possibilities. Chalk out in the sense, let me just put it out, the different possibilities for velocity time graph for this particular case, right? Fine. So this is velocity, this is time, right? This is velocity, this is time, this is velocity, this is time. Now one of the possibility is how it was like this. This is obviously one of the possibilities for the velocity time graph. Means the velocity could be actually varying like this. Now the thing is that velocity can be negative, but speed cannot be negative. You know, velocity can be negative, but speed cannot be negative. Now what if in this part, for this part, what if the velocity was negative? So there could be a possibility like this. The graph, the velocity time graph could be like this also, right? For this part could have been negative, or another possibility is that this part could have been negative. So another possibility is this, right? Now this is amazing, and I am really liking this question. It has made me think a little bit. Generally I don't think before solving any question, but a little bit I had to think. So that's, you have to give it that, right? Fine, great, amazing. Now see here, so let us calculate the average speed for all the possibilities. This is 1, this is 2, this is 3, right? So in first case, the average in the first case, what is the possibility for average in the first case? The possibility for average in the first case is V2 minus V1. So what will be V2? V2 and V1 both will be 20. Yes or no? V2 and V1 both will be 20. So 20 minus 20 by T2 minus T1 will become 10 minus 0, that is 10. So that becomes 0. So one possibility is 0, right? Another possibility, the average acceleration, another possibility for average acceleration from the second one. What is the other possibility? What is the other possibility that we have? So here final velocity can be negative 20, you can see here the final velocity can be negative 20 and initial velocity could be positive 20, right? Negative 20 and positive 20. So what will be the final velocity? Final velocity will be minus 20, initial will be just 20 divided by 10. So minus 40 by 10, right? So minus 40 by 10 becomes minus 4 meter per second square. So minus 4 meter per second square is also a possibility. So now I'm sure you can understand where this question is heading, right? Are things visible? Maybe something is getting hidden behind me, right? But yeah, this is great. I'm writing everything on this side. Amazing idea. Now lastly, average, third one. What is that? That will be again V2 minus V1. So here you see final velocity will be plus 20, this will be plus 20, this is minus 20. So final is 20, initial is minus 20 divided by 10. So that becomes 40 by 10, that is 4 meter per second square, right? So what does that mean? That means all the possibilities are there. So here answer could be 1, 2, 3 all. So answer should be the fourth option here, right? Okay, great. Good question. Keep up the energy. Test your concepts really well. Now tests your concepts really well. Now let us see the next one. Moving on, right? So this is the 11th question, again based on velocity time graph. Let us see what we can do here. What we can do, we can solve, but obviously what logic, what concept we can apply here, that is what I meant, right? Okay, great. Let us see this one. So the question says, figure given below shows the graph of velocity v of particle moving along x-axis as a function of time. Average acceleration during t equal to 1 second to t equal to 7 second. 7 second, 7 is, I think 7 is the printing mistake. So we just need the average acceleration between t equal to 1 to t equal to 7. Now another good question, because again this is not direct, you have to do a little bit of analysis here. So let us see how to do that, right? So average acceleration. What will be the average? What is the formula for average acceleration? This is velocity time graph. We need average acceleration. What is the formula for average acceleration? Change in velocity by change in time, right? You all know, we all know, you all are great. Excellent. So change in velocity will be v2 minus v1 by t2 minus t1. v2 minus v1 by t2 minus t1, right? Now what we can do? What is v2 here? Final velocity. So we need velocity at 7 seconds. How can we figure that out? How much will be the velocity at 7 seconds? We can apply the midpoint here. You can see the x7 is the midpoint between 6 and 8, right? So x coordinate is the midpoint, then the y coordinate will also be the midpoint. Since it is a straight line, slope will be same, and yes, the variation will be similar. So it will be a midpoint. You can figure that out, or you can write the equation of this line. I think it will be simply the midpoint. You can directly calculate. So this will be, since the x coordinate is the midpoint, y coordinate will also be the midpoint. So this will be 25, right? This value here is going to be 25, and this is your 7, right? Clear? Following everyone? All right. All right. Yeah. V2 minus V1. What is V2 here? So V2 is, man, we need between t equal to 1 to t equal to 7, right? So for 1 also we have to calculate. So they want us to do a lot of calculation. I hate it. I simply hate it. Just give me the answer, man. You're not using a very big concept here. The question is not very difficult. Unnecessarily trying to make it lengthy. I don't know what were they even thinking, but good thinking, obviously. So this is 1 and this is the midpoint. So again, since x coordinate is the midpoint here, the y coordinate will also be midpoint. So this will be 15, right? So what will be v2? v2 is 25. So velocity at 7 seconds is 25, and velocity at 1 second. At 7 it is 25, at 1 it is 15, right? Clear understanding, everyone? Any confusion? Right. Moving on. Moving ahead. Okay, let's do the work. Not much of talking. 25 minus 15 by 7 minus 1. 7 minus 1 is 16. So how much will be 25 minus 15? 25 minus 15 will be how much? It will be 10 by 6. 10 by 6, which is 5 by 3. 5 by 3 will become 3 6 ja 18. 3 1 ja 3, you have to give, obviously. Oh ho ho. Did I make a mistake? I don't think so. I don't make mistakes. Come on, man. I'm beyond that. Yes, I did make a mistake. The midpoint here will be 10. What a silly mistake. This will be 10. So that is 10. Things are going to change around here, right? Okay. Don't judge a cover by its book, right? It's fine. So just a silly joke. 25 minus 10 is 15 and 7 minus 1 is 6. Teach like no one is watching. There's a phrase, dance, you dance like no one is watching. So I'm going to teach like no one is watching. Understand? And that's true. Sadly, that's true as well. Since no one is watching, I can do whatever. Right. So 15 by 6. So 3 to the 6, 3 5s are 15. 5 by 2, 2.5 meter per second square. So answer will be the fourth option, 2.5 meter per second square. Great. Excellent. Moving ahead. Okay. Quite a lot of questions I have taken, right? I should have taken a little less questions. Selective questions you do. I think I will leave some questions for you to do as homework also, right? तो इस क्वेश्चन का आंसर, इस ट्रिक को लगा के इस क्वेश्चन का आंसर कमेंट बॉक्स में लिखें, वीडियो को लाइक एंड शेयर करें, और इससे और प्रैक्टिस वीडियोस के लिए टेसरैक्ट लर्निंग और व्हाटएवर विल बी द फ्यूचर नेम उसको सब्सक्राइब करें, राइट? सो these two questions I'm giving you as homework. You go home, do it on your own. I don't want to do it. As simple as that. So because we have already done a lot of questions on how much 11 questions already. When will we teach? Right, so I'm giving you these two questions of homework. So you do these two questions as homework. So we are going to continue now. Okay, let us see. Now let us see some questions on acceleration time graph. If you have any doubt, any confusion, you know what to do. Do I have to tell you? Just put it in the comments, man. Yeah. You can always reach out to me through the comments. So 12 and 13 is homework for you, right? Note it down. Great. Moving ahead. I want to crop it. I want to crop it the way it should be. Nothing extra, nothing less. Right. Let's do it. Question number 14. 14. Right. Right. What does the question number 14 says? They're saying the acceleration time graph of a particle moving in a straight line is as shown in the figure. So they have given the acceleration time graph of a particle moving in a straight line. The velocity of particle is at t equal to 0, velocity of particle is 10 meter per second. What is the velocity at t equal to 8 seconds? Right. Oh, great stuff here. Okay, no problem. We can do it. That's not an issue. Only issue is this question correct? Yes or no? See, the confusion that I'm having here is this question correct? Is this question correct in the sense there is no sense. Sometimes a sense has to be there, but it's not there. Right, so what can we do now? Okay, let's do it anyhow. Fine, they are given the acceleration time graph of a particle moving in a straight line is as shown in the figure. At time t equal to 0, velocity of particle is t 10 meter per second. What is the velocity at t equal to 8 seconds? So see here, the simple idea is, the idea is very, very simple. The idea being that area under acceleration time graph gives change in velocity. Okay, area under acceleration time graph gives change in velocity. So we have to find area till 8 seconds. That's the only thing here, right? So change in velocity will be integration a dt, which means area under acceleration time graph. Okay, so area under acceleration time graph is going to give you change in velocity. Fine, that will be equal to the area. So change in velocity will become, and how much will be the area? So we need this area plus, this is the area plus this area. How much? The only doubt that I'm having here is whether this part, is this part there or not. Okay, I'll just do it. Fine, use the concept. There could be some mistake here. I'll just do it based on what I perceive the best thing to do is. Right. So see the initial velocity at t equal to 0, they have given the velocity as 10 meter per second. So change in velocity is final velocity minus initial. Initial is 10. Now how much will be the area? So first we need this area. Now how much will be this particular area? A1. Right. So that area will be, that's a triangle. Right. So for a triangle the area is half into base into height. Right. Simple thing. The area is half into base into height. So half into the base here is 6 into 2. So that is the positive part of the area. And there is a negative part of the area as well. What will be the negative part of the area? So that's the confusion that I'm having. We are not sure this is corresponding to which particular point. This is this is 6, 8. Maybe that's this corresponding to 6, 8, and then you have what? 10, right? So we need what is the velocity at this particular point. So if that is the midpoint, yeah, there are a lot of confusion here that has been created. There's a printing mistake. Okay, just give me a moment. Just let me check it out on the go, right? Right, so it's gonna take a little bit of time and setup will get damaged, interrupted in fact. So let me just assume some values and do it for the concept part. We can clearly see that this, if this is -6, this will not be -6. So there's a printing mistake for sure. So this should be -8, right? This particular point here should be -8. Okay, great. Fine. So that is -8. What will be the midpoint? We need the midpoint, right? So between 6 and 8, so midpoint will be between -8 and 0. So that should be -4. This should be corresponding to -4. That's what I'm guessing. Okay, this should be -4. Otherwise it will be difficult to solve, right? So this length will be -4 and this is 2, right? So now the another area A2 will be this particular area. This particular area will be your A2, right? So we need that area as well. So how do we do it? So plus, how will we get that area? So that will be negative. Okay, so that will be negative. Half into base is 2. Either you can take this as -4 or altogether you can take the area as negative. That is also fine. Just take the magnitude and then take it as negative. So that also you can do. So here 2 gets cancelled. V minus 10 will be equal to 6 minus 4. 6 minus 4 will be 2. V will become 10 plus 2, 12 meter per second. So we have the answer. That means whatever values we assumed was correct. There is certain error in the question for sure. Fine. So answer should be the fourth option, which is 12 meter per second. Okay, right? Clear? Excellent. We'll go for next part now. We'll go for the next question. So we have another question based on acceleration time graph. So let us do this. Right, fine. So have a look at this particular question. So this will be question number 15, right? This will be question number 15. Fine, right. See what the question says. Let's go through the question. Question says a particle starting from rest undergoes a rectilinear motion with an acceleration a. Particle starting from rest, it moves. Rectilinear motion means it is moving in a straight line with an acceleration a. The variation of a with time is shown in figure. The maximum velocity attained by the particle during its motion. So they have given an acceleration time graph and they are asking what is the maximum velocity that will be attained by the particle, right? So again, this is also an interesting and important question, important concept you have to understand here. How will you figure out the maximum velocity attained from this particular graph? So at first glance, when you look at the question for the very first time, the question seems very vague, or you can say, what can we say, ambiguous. It feels like not ambiguous, kind of, I'll say the better word will be difficult. Yeah, how exactly will you figure this out? Just from the acceleration time graph, how will you figure out the maximum velocity, right? So there is a way to do it. There's obviously a way to do it. How we can do it is, see, area under acceleration time graph gives change in velocity, and as long as the area is positive, the change in velocity will be positive. That means as long as area under acceleration time graph is positive, the velocity will keep on increasing. Fine. So whether the acceleration decreases, that does not matter. Even if the acceleration is decreasing, but if the acceleration is positive, even if the acceleration is decreasing, but if the acceleration is positive, velocity is only going to keep on increasing. Okay, velocity is only going to keep on increasing. Why is that? Because even if the acceleration is decreasing, as long as it is positive, decreasing acceleration only means the rate at which the velocity will increase will decrease, and the rate at which velocity will increase will decrease. Now you might say, what is that? What exactly are you saying? Like for example, if acceleration is 10 meter per second square, then the velocity will be increasing by 10 meter per second every second. If acceleration is 8 meter per second square, velocity will be increasing by 8 meter per second every second. If the acceleration is 6 meter per second square, that means the velocity will increase by 6 meter per second every second, right? So even though the acceleration is decreasing, that only means that the rate at which the velocity will be increased, that is going to decrease. But overall, the velocity will be changing only, right? I explain this with a silly example. Like suppose if I am giving you 100 rupees per second, right? If I am giving you 100 rupees per second, after 4 seconds, how much money you will have? 400, right? Now suppose if I started giving you money at the rate of 50 rupees per second, so after another 4 seconds, how much money you will have? Some will say 200, but that's not correct. You will have 600, because initially the 400 that I have given, I have not started taking from you. That money is still there with you, right? Only thing is that now I'm still giving you money, but at a lower rate, right? But at a lower rate in the sense, I'm not giving you a large amount of money in a small amount of time. And the rate at which I'm giving you money, that only has decreased, but I have not started taking money from you, right? So now suppose if I decrease the rate to 20 rupees per second, so after another 4 seconds, how much money you will have? So initial 400, next 200 plus 20 into 4, 80. So 680 rupees will have. Understanding what is happening? So the rate at which the velocity will decrease, that is going to increase, but overall the velocity will keep on increasing. So as long as acceleration is positive, the velocity will keep on increasing. So maximum velocity will be attained till 12, because till the point the area is maximum, the increase in velocity will be maximum. So if the increase in velocity is maximum, the velocity value will also be maximum, right? Fine. So change in velocity will be equal to area under the acceleration time graph, which is half into 12 into 10, right? So this change in velocity only will become the maximum velocity. The particle starting from rest, so initial velocity is 0. So whatever is the final velocity, that only will be the maximum velocity. So this becomes 6, that will be 6t. So Vmax will come out equal to 60 meter per second, right? Okay, great, clear. Okay, let us go for the next one. Next is this. Next, another question based on acceleration time graph. So you can see, based on acceleration time graph, similar type of questions come most of the time, where they have given the acceleration time graph and you need velocity at any instant. So from acceleration time graph, mostly the question will be based on the area part only. Okay, from acceleration time graph, mostly the question will be based on the area part only. That is something you need to keep in mind. Okay, great. So here also same thing. So I'm not going to solve this one. I'll just tell you how to do this. Okay, and we'll proceed. So they're saying if the particle starts with a velocity 2.4 meter per second, that means the initial velocity is 2.4 meter per second. Right, initial velocity is 2.4 meter per second. Then they are asking the velocity at t equal to 8 seconds. How much will be the velocity at t equal to 8 seconds? So see, area under acceleration time graph. Area under acceleration time graph gives change in velocity, right? So change in velocity will be equal to the area under the graph, right? So we just need this area. So final velocity v minus the initial velocity 2.4, final velocity v minus the initial velocity 2.4 will be equal to this area, right? And so calculate the area till 8 seconds. You can divide it in rectangles and triangles and all. You can figure out the area and you will get the answer. Fine. So solve this for the answer. Fine. Right. We'll go for the next question now. What is this question? Right. So from here, now what you're going to do, we'll see some miscellaneous graphs, or do we have anything else left? Okay. So we have this graph conversion questions, right? Let us see this. This looks like an interesting question. Question number 17, which is based on graph conversion. Okay. See what the question says. Question is saying the velocity time graph for a particle moving along x-axis is shown in the figure. The corresponding position time graph is best represented by. So they have given the velocity time graph. We need the corresponding position time graph. So how will be the corresponding position time graph? Fine. So see, we can solve it from the graph itself. So we can solve this question from the graph itself. Let us have a look here. So see, this is velocity time graph, this part and this part. So what can we say here? So if you see initially here, what happens is that in this part, velocity is positive and it is increasing at constant rate. So here the acceleration is positive. And here also, in this part also, actually, for here also velocity is increasing, here also velocity is increasing. And you can see slope for this part will also be positive, because this will also make an angle less than 90 degree. This angle will be acute, right? This angle will be acute, theta less than 90 degree. And this angle here will also be acute only. Fine. This angle will also be less than 90 degrees. So that means that acceleration is positive for both the parts. For both the parts of the graph, the acceleration is positive. So just from that information, positive constant in fact. And acceleration is positive constant. Right? So since the acceleration is positive constant, the graph will be an upward parabola. Okay, so graph will be an upward parabola for this part as well as for this part. So where is that happening? This one. See here, this is the downward parabola, not possible. Acceleration should be negative. So this is upward parabola, this is part of upward parabola, and this is also part of upward parabola. And you can understand also, like initially the velocity is increasing and positive, so position is increasing. Then suddenly the velocity becomes negative. The particle starts moving in opposite direction. So position will be decreasing. But if you think in terms of parabola, both should be upward parabola. So the best answer will be option 1 here. Okay. Both should be upward parabola. So the best answer will be option 1 here. Clear? Great. Let us see the next one. Right. So here now we have one last question is there. Those are different type of questions, so that I'll explain. later. Okay. This is based on conversion of graph. So you also get questions where you might have to convert from one graph to a different type of graph. So this was 17. Next we have question number 18. Right? Fine. See what the question says. Question says the velocity time graph for a particle moving in a straight line is shown in the figure. We need the corresponding acceleration time graph. So they have given the velocity time graph. We need the corresponding acceleration time graph. So how we know that acceleration will be given by the slope, and acceleration will be nothing but the slope of velocity time graph, right? Acceleration will be nothing but the slope of velocity time graph. So the main thing that we need to figure out here is how will the slope of the velocity time graph be varying. Okay, how will the slope of velocity time graph be varying? So how will the slope vary? So if you see here in this part the slope is negative, for this part negative slope, for this complete part you have positive slope, and again for this part you have negative slope. Fine. So negative slope, positive slope, and negative slope. So how will be the graph, right? Negative, positive, negative, right? So negative, so acceleration should be initially constant negative, then constant positive, then constant negative, right? So slope is negative, positive, and negative. So acceleration should be negative, positive, and negative. So that happens in the third option, right? Fine, great, clear. Fine, so we'll keep it till here. In the next class we will see a few miscellaneous graph like Vx graph, Ax graph, V square S graph. So we have some miscellaneous graph as well. So we'll see that in the next lecture. Fine. So we'll keep the lecture short, 30 to 45 minutes max. If it gets longer, I get bored, you get bored, the learning is not happening, right? Fine. So we unbox, we will end this session here, right? Okay students, bye bye, see you in the next one. Until then, keep learning, keep growing. You all are great, you all are the best.